Welcome to my channel. I'm Zhang Xu. Let's look at the problem 24 in chapter 25. Chapter 25 is about electrical currents and the resistance. So there we can see this is one application about the resistance to check the deform of the wires, right? And you can see initially we have the wire's length is L0 and the cross-sectional area is A0. And finally, this wire just deformed, just changed, right? Just extend or something, change the shape. The length is L, the cross-sectional area is A. And we know if we extend this wire, the volumes will not change, right? Its volume is constant. So in this way, we can write the A0 as V over L0, the cross-sectional A as V0 V over L. Do you agree from this equation? Yes. Now you can see we need to find the string, that is the change of the length over the L0 must equal to the change of resistance divided by 2 times R0. So how to prove it? So very straightforward, if we want to connect the length with the resistance, normally we can consider the function, the resistance equal to rho times L over A, right? So initial situation, the initial resistance R0 is rho times L0 divided by A0. There, as we talk about, the A0 can be replaced with the V over L0, right? So we put it inside. Similarly, when look at the final resistance, so you can still use the rho times L divided by A, and this A replaced by V over L, so it looks like this one. Now it looks like we need to find the change of the length with the change of the resistance, right? So from this function, you can see the R is a variable, rho is constant, V is constant, L is constant, right? So it looks like you can find the change relationship between R and L by using derivation. So from this function, you can see the derivation dr equal to rho 2L divided by V dl. Do you agree? As we talk about, the derivation is a limitless small fraction of changes, right? So we can consider this dr as delta R. This is the change of resistance. This dl as delta L. Agree? Yes. Now you can see, solve this equation. You can get the delta L in this term. And you can see there we need to find a string, that is a dl over L0. So we don't know where is L0, but we can divide by L, right? If we use the delta L divided by L, we get the term at there. Simplified, it looks like this one. Very close to our final answer. There, if we consider this L is L0, the R must be R0, right? So then we proved it. Thank you.